The mean incubation time for a type of fertilized egg kept at 100.4 degrees Fahrenheit is 22 days. Suppose that the incubation times are approximately normally distributed with a standard deviation of 2 days. What is the probability that a randomly selected fertilized egg hatches in less than 18 days? So let's find out what's important first. So we have that the mean is 22 days, and they're approximately normally distributed, and the standard deviation is 2 days. We're looking for the probability that it hatches in less than 18 days. So we're looking for the probability that X is less than 18. So we're going to draw on our picture here. Our curve. And our mean here is 22. And let's just go ahead. So standard deviation's 2, so this would be 20 and 18 and 16, since we have nice 18 days here. So we want to know the probability that it hatches in less than 18 days. So less than 18 days, right? So we are calculating a probability. So we have two different functions that we learned about, normal CDF and inverse norm. So when we're looking for probability, we use normal CDF. So normal CDF and our lower bound here is going to be negative 1e 99. And then we're upper bound here, we're going up to 18, so that's going to be 18. Our mean is 22. And our standard deviation is 2. So we're going to calculate that here. And we usually round to 4 decimal places. So second bars 2. Negative 1 E99, comma 18, comma 22, comma 2, and close our parenthesis and enter. So 0.0228 there is our probability. Next example, we want to know the probability that a randomly selected fertilized egg takes over 26 days to hatch. So let's draw on our picture here. It doesn't have to be exact. I usually just put a meaning here. And we want over 26. Over 26. So we're looking for the probability that X is greater than 26. So that's going to be equal to normal CDF. So we're looking for probability. And our lower bound is 26. Upper bound goes on forever, so infinity, so positive 1e99. And our mean is 22, standard deviation is 2. So second bars 2, 26, comma 1, E99, comma 22, comma 2. So that is 0.0228, right? Makes sense, right? And our 2 standard deviations, that's the metric there. Right. The next part, we want to know what's the probability that a randomly selected fertilized egg hatches between 20 and 22 days. So we have our curve here, and our mean of 22. 20, and we're looking for this area under the curve or that probability, same thing, right? So we're looking for the probability that x is between 20 and 22. So this is going to be normal CDF. And 20 is my lower bound, 22 is my upper bound. My mean is 22 and my standard deviation is 2. So we're going to do second vars 2, 20, 22, 22, 2. So 0.3413 there. And then last part, we want to know, would it be unusual for egg to hatch in less than 19 days? So we're going to look for the probability that x is less than 19. So I'm drawing our picture here. 22, we want less than 19. So we're looking at normal CDF, negative 1e, 9, and then 19 is our upper bound, mean is 22, standard deviation is 2. Let's see what we got. So second vars 2, negative 1, E99, comma 19, comma 22, comma 2, close our parenthesis, enter, negative, sorry, I don't know why I said negative, you get 0.0668. So this is not unusual. So no, it would not be unusual since the probability that x is less than 19 is greater than 0.05. So remember, for that to be unusual there, we want a probability of less than 5%.